Hi, thank you so much. Yeah, I appreciate the introduction. And yeah, Dean bringing the fire as usual, which was fantastic to hear. So thanks everybody for having me. Like Roland just said, I'm Patrick from Chainlink Labs. I work on the Chainlink project, and I am the developer advocate. So I help engineers get set up. I do education pieces like this, and talk about smart contracts and blockchain, and just beyond excited because we're really in this insane place right now. I know everyone's kind of been talking about it, but yeah, I mean, DeFi is massive. DeFi has recently blasted off, and a huge part of that is because we have created definitive truth for specific pairs for specific pieces of data, so that people can actually build reliable, decentralized smart contracts that don't have to depend on any single centralized entity. Obviously, that's what decentrality means. So with that, getting this data is critically important. Getting this reliable, decentralized data is what's going to bring these smart contracts from just doing token transfers to actually being able to do really, really interesting things, and using blockchain to its fullest potential, and really unlocking blockchain. So in this presentation, I'm basically going to be talking about Chainlink and smart contracts, and how Chainlink basically unlocks them, like I was saying, to do these really amazing things and unlock this fourth industrial revolution that we're steamrolling towards. So just kind of a quick overview of what we're going to be going over today. We're going to talk about the smart contract connectivity problem, how Chainlink is already supporting the growth of DeFi. We had Keenan earlier go over DeFi and why it's important, and I'll touch on that a little bit as well. Untapped potential and some tools and resources you have to build Chainlink smart contracts. So we will not be going over the remix demo. There's a fantastic Agoric Chainlink demo put together by I believe it was Mike and probably a couple other engineers there as well. But yeah, that'll be we'll be going over that demo next week on Monday, actually. So stay tuned for that. But so basically, in order to really understand Chainlink, we first need to really understand what smart contracts do, and how they're not able to connect natively to external data or any off-chain resource on their own. And this is a huge limiting factor for smart contract adoption, because again, this means the only thing that they can do is token transfers. I can send John 12 Bitcoin or 12 ETH or 12 or whatever cryptocurrency that you're using, right? And this is nice, but it doesn't allow for us to have these agreements. So for those of you who are a little bit more technical, the question kind of comes up is, hey, well, why can't a blockchain just make an API call? Why can't a blockchain just do what every other system does to get data? And this is actually a really, really important question. And the answer is because blockchains are deterministic. This is a really, really important concept. They need to be deterministic in order to be validated by all other nodes on the chain, right? So if you were to replay any blockchain from start to finish, you should end up in the exact same state every single time. This is part of what allows these consensus protocols to work effectively. If we had random data, or not random data, but if we had APIs that can change, get updated, or hacked, be part of the consensus protocol, then two nodes are going to go to validate someone's API call, and they could be wildly different, right? So if a node makes an API call to check the weather API says it's 76 degrees, and they put that on chain. Another node goes to validate this, and the API changed that the half second later that they checked it out now says it's 77 degrees. Well, now they can't agree on what the state of the blockchain is. So they can't make these API calls natively. They can't get this data by themselves, and that's why Chainlink and oracles are really necessary. So this is something, I'm harping on this because it's really important. Blockchains are deterministic systems, and they're intentionally deterministic systems. So to interact with the outside world, because obviously we still want to, in order for smart contracts to do interesting things, we need to use what's called an oracle. Now, an oracle is any device that interacts with the off-chain world to provide data with smart contracts. And additionally, you can do the reverse of that too. You can use an oracle to send data or send requests from a blockchain. So due to some interaction on chain, you would use an oracle to do something off chain. So oracles are really the bridge or the middleware that connects the real world to any blockchain that you're using. So and yeah, they report the results of that data that's on chain, so that the blockchain can stay deterministic. The way that they do this actually is when you make a transaction on the blockchain, it actually puts whatever data that you would normally want to get into that transaction and puts that on chain. That way it can stay deterministic, but you can still work with this external data. So it's really, really important to keep that in mind. So this is where Chainlink comes in. You know, there are thousands of APIs out there that are already providing data that people need for their applications. And Chainlink makes it really easy to enable connectivity between those APIs and smart contracts, even if they require authentication. So that now you can have decentralized applications powered by the same exact reliable APIs the rest of the world and current web applications use today. So a single Chainlink oracle is also known as a Chainlink node. I'll use them a little bit interchangeably here. So now a lot of users today still don't really understand blockchain, right? Sending payments in cryptocurrencies isn't universally accepted yet. And when a smart contract is executed, we need the ability to get paid in a currency that we want. So Chainlink makes it really easy for these off-chain payments to take place based off these on-chain interactions. This also works for cross-chain communication and sending payments to other chains. Chainlink uses this concept called external adapters. And for those of you who are going to go to the Monday workshop, we'll see them actually in practice. And we'll talk more about them on Monday, like I said. And these allow connectivity between any resource, be it an open API, an API with authentication, payments API, or different blockchain. Really, they're this core functionality that allows Chainlink to be customized in any way that you want. Literally, even more interesting is work automation, which we're starting to see more and more people use. Like, you know, something happens on chain, and instead of, you know, sending a payment, instead of accessing an API, it triggers, you know, some off-chain service to start running. And you can have a decentralized task being done off-chain as well. And the external adapters is what allows that to happen. So they're really insanely powerful and allows for Chainlink to do whatever you want it to do, which is really, really fantastic. So yeah, you can use these to provide authentication, processing, reduce, you know, gas on chain. And external adapters can be written in any language that you want, and they only need to react to specific requests sent to a Chainlink node. So because of this, you actually don't even need to be a Solidity engineer or a JavaScript engineer or an Agoric engineer or a blockchain wizard to build these external adapters. You can really, you know, build them in whatever language that you're currently familiar with. Now, here's where things get a little bit more interesting, and in my mind, this is really the really important piece of this whole thing. So oracles are great, right? They get data on chain and they send data off chain. However, if you send data or get data through a single centralized oracle, you now have a centralized point of failure for the entire smart contract. This basically defeats the purpose of you building a decentralized smart contract in the first place. So, you know, the reason that blockchains are so fantastic is because there's decentralized entities. You no longer have these centralized sovereign governments over currencies. You no longer have these, you know, centralized corporations that control, you know, the task automation. It's, you know, you build these decentralized smart contracts. So if you're going to build the decentralized contract, but get your data from a single point, that data provider now has control over your entire contract, right? You know, something really simple. Let's say you build a decentralized stock exchange, but you're getting your price feed from a single data provider. If somebody bribes that data provider to say, hey, you know, make the price of Tesla $100 more expensive, they now ruin your decentralized smart contract, and it's no longer decentralized. Oh, did the page, what? Oh, did we lost the page for a second. Okay, but we're good. But yeah, you basically ruin and lose the decentrality of your smart contract. So this is massively important to avoid. And it's also not only the data provider, but it's the node that delivers the data as well. So that if the data provider is centralized, you get this issue. If the oracle is centralized, the data is flowing through one oracle, they can manipulate the data and then send it on its way. So this is really, really bad. We never want to have a single centralized oracle. For the most part, there's one exception, and I'll go into that into a little bit. But so saying a centralized Chainlink node by itself is decentralized is kind of like calling a tree a forest. A single entity does not make up a whole, right? To make applications truly decentralized, you need to have a network of Chainlink nodes or a network of Chainlink oracles. And we'll go over that in a little bit as well. And so, the reason why I'm stressing this point is not just some, watch out, but this has actually already happened, right? We've seen attacks where projects have lost, literally millions of dollars since their centralized Oracle feed was hijacked. So this isn't, just voodoo or random stuff. Where we've seen decentralized applications proclaimed decentralized application go to ruin because they were secretly centralized with the Oracle sources that they were using. So Chainlink is designed to be this modular infrastructure, and you can build a decentralized Oracle network used to connect smart contracts to any API. You can select as many Oracle nodes or Chainlink nodes again as you like, and use as many data sources as you like in order to trigger the execution of your smart contract. So, then again, Chainlink enables, these additional off-chain interactions like payments or work automation to occur based on the execution of your smart contract. So if the result of a smart contract said that somebody, needs to be paid $100 USD, you can utilize Chainlink to actually send this exact transaction. So again, this is what makes it so powerful is you have this network of nodes that, the decentralized smart contract says, hey, we need to do something, and the oracles do it as a whole. And if one or two, in the same way that makes blockchain secure, if a number of Chainlink oracles are malicious or behave poorly, the decentrality of the network allows it to persevere and carry on. So it's really, really important. And to get you started with DeFi, the Chainlink project has actually gone ahead and found many of the best blockchain node operators on the planet and combined their prowess to build what's called price feeds. Now, these are decentralized on-chain reference points that can be considered a source of truth for various currency pairs, like the price of ETH in terms of USD, for example. And these are, at least right now, by far the most popular use case of Chainlink, and there's good reason why. These price feeds are securing literally billions of dollars in the Ethereum chain right now. I'm getting a little bit ahead of myself. I'll talk about the DeFi use cases in a second, but a little bit more about these price feeds. Each node in the network independently gets data from some of the highest quality data APIs and reports their answers back on chain. You can actually see the answers that these providers are reporting, and everything is transparent. So if you look at this little visualization here, all those nodes circling that one point in the middle, that's and the numbers associated with them, that's the answer that they're reporting. So you can see if someone is being malicious. If someone's being malicious, you just kick them off the network. So everything is incredibly transparent, and then all their responses get aggregated in the middle. That little shield check mark, that is the aggregated answer of this decentralized network of Chainlink oracles, and this is what makes it so powerful. Is, as you can clearly see, if a bunch of these go down, the network is still going to continue. The network is still going to work just fine. You can check out that page at feeds.chain.link. It's got a lot of really cool visualizations and you can learn a lot about the Chainlink ecosystem by kind of like going through some of those pages. So in DeFi right now, and I know Keenan kind of went over some of this too, these price feeds are already being used by a slew of some of the top DeFi projects around the world. The proven safety, reliability, and power of these applications is a testament to the power of the Chainlink and the price feed. So you can see a couple of them here, across all DeFi platforms, synthetic assets, lending and borrowing, trading, asset management. There's a reason that so many of the top projects in the DeFi space are using Chainlink. And so this was a snapshot of maybe a month back of what's called DeFi Pulse, and that page changes on an hourly basis because of the whims of the crypto market. But it shows at the time 5 of the top DeFi projects and how much money was actually locked. And if we look at this graphic right here, we see 3 of the top 5 projects are using these Chainlink price feeds, namely Aave, Synthetics, and Yearn.finance. And the reason, again, that they use them is that it just works. It's safe. You get your data in super easy. It's probably one of the easiest pieces of data to integrate in any smart contract. And I've heard Mark from Aave say a couple of wonderful things, like Chainlink is the holy grail of DeFi, and the best part about Chainlink is that it just works, and that's really what we strive to do, is have things just work. So Synthetics, just a couple more stats here. Synthetics at 900 million, Loopring 20 million, Set Protocol 20 million, Aave 1.5 billion with a B. So these are highly secure. They're clearly being battle tested. They've been battle tested, and these are some of the applications that still trust them to today. So, and in addition to getting any API or working with any off-chain data, something that's been really, really tough, and I could honestly spend an hour talking about this, but I don't have an hour. Something that's been really tough, and if any of you engineers are out there, getting random numbers is an issue in computer science. The reason it's such an issue is because computer science and computer systems are deterministic systems, right? So imagine, so it's already hard enough on a regular computer system, but in a deterministic blockchain, getting a random number is even harder, right? Determinism, if you know what the result of everything is going to be, how are you ever going to get a number that's really random that nobody can predict, right? So it's been incredibly difficult, and the conventional ways up to this point to get random numbers has been using the block hash. So an engineer would write their script and just kind of like hash the block hash, use that as their random number. But we've seen issues with this. We've seen projects have a really hard time and be attacked because of this, because this keeps them open to the at least one attack vector of miners actually attacking them. So imagine a situation where you're a miner, you signed up for like a lottery on a smart contract where the payout is $1 million, and you're mining blocks, and you mine a block that would be the winning hash. However, you look at the hash and you realize that it's not your number. It's not your number that you win. So what do? You just don't publish it. You just throw the block out, and essentially the miners have now ruined the fairness of the game. Right? They've ruined the fairness of the lottery. And even worse, if a pool of these miners get together and maybe, as little as 2%, and they just start throwing out blocks that they mine because, those blocks aren't winning, they're highly incentivized to do so, right? Because their payout could be something like $1 million. And whenever they throw out a block, I'm going to use Ethereum as the chain here. Whenever they throw out a block, they're only really foregoing like 1 or 2 or 3 ETH. So they're actually, it's a rational choice for them to throw out a block to forego that that reward so that they can get that much bigger reward. But I lost my train of thought here. But anyways, so the Chainlink VRF is a way to provably request a random number from a Chainlink oracle from this off-chain service. And the interesting part is the part that's kind of the crazy crypto magic in my mind is that when the node actually returns the answer, the on-chain VRF coordinator can actually verify if that number was random or not, which is kind of insane, saying that this is a provably random number. I don't think that this is something that I've never seen even before blockchain, having provably random numbers in your system. And this allows you to have these provably fair, these provably secure, games, medical sampling, drafting, stats, whatever you want to make, you can have provably random numbers. And this is something else that Chainlink enables. And we're starting to see more and more adoption here. Pool Together, Avagochis is working on it. There's a number of projects that have realized how powerful this is for their application. So I'm popping off a little bit, but let me move on here. So, and then just to kind of quickly summarize, we've seen, 3 of these incredibly powerful use cases, right? Chainlink allows you to get and send any data between any blockchain. It allows you to get these. It allows you to get these provably random numbers, and then it also allows you to get these certified, definitive points of truth on chain for whatever pricing and right now, or for whatever data. And like I said, right now, price data is kind of the most popular definitive truth, but really anything, the sky is the limit. It's really creativity is the only bound in this case. So we have an article called 44 Ideas for Smart Contracts. This is just kind of a list of ideas. If you're coming to this hackathon, you're like, I'm not really sure what to build. Hopefully this gives you a little bit of insight. So, and these are some of my favorites. So DeFi, obviously, DeFi is massive. The Agoric chain, in particular, is set up really, really well for DeFi. So just any type of any traditional finance application that can be DeFi'd or DeFiified is perfect for building something here. DeFi is massive. We're not even close to hitting the market cap of like current systems. So there's so much space to improve here. Fantasy sports or really any gaming. These are massive use cases that we're looking to see more and more of now that VRF in particular is out, and getting these random numbers is a lot easier. Tokenized assets is absolutely huge, like splitting up a car, a plot of land, shares of a stock. It makes it really easy to keep track of who owns what without having to deal with any of the paperwork, right? And since your data is coming from these decentralized Chainlink oracles, nobody can mess it up, and nobody can tamper with your data or be like, oh, I lost the paperwork, because it's all on chain. Insurance is probably one of my favorite use cases here. And it really hits home, and it's kind of like one of the easiest ones to really understand why blockchain and smart contracts need to come sooner rather than later. The example I normally give is farmer and crop insurance. Imagine all your crops get destroyed due to the weather, and your insurance that you've been paying doesn't want to pay out because of some pre-existing condition. This is perfectly exemplifies the conflict of interest between policyholders and their clients. It's in the insurance provider's best interest to find these loopholes and screw over the client, because that's how they can make the most money. So they're financially incentivized to do this, and maybe they withhold their funds. And sure, maybe you go to court, but 6 months or a year of court procedures and you still haven't gotten paid. Maybe you needed that money to pay medical bills. Maybe you needed to not get evicted from your home. So these are, to me, this is kind of like one of the biggest calls to actions and needs for smart contracts to come to life is insurance. Obviously, everything else that I said is obviously massive, and it's really hard for me to pick. But I feel like this one's one of the easier ones to kind of get that emotional connection with. And with a decentralized smart contract, you don't have to trust that the insurance company or the insurance provider is going to do the right thing, because the right thing is actually infrastructural with Chainlink. So with that, I know I have like 5 minutes left. I think I'm still sharing this screen. How do I? Let me switch screens real quick. Oops, spelled docs wrong. For those of you builders looking for a place to start, looking for where to go, let me actually expand this. The Chainlink docs are really going to be your home. The Chainlink docs and actually this Agoric Chainlink. Spelled Agoric wrong. And this repo right here. These are going to basically be your homes. This has a step-by-step kind of how to get started with Agoric and Chainlink. If you, am I streaming on the right page? Yeah, I'm not streaming on the right page. Sorry, I'm streaming on this tab. This GitHub repo, you can literally step by step. And like I said, on Monday, we'll actually go through this repo doing it. Before you do any of this stuff, be sure to go through this documentation here. You're going to need to do that in order to do anything here. But once you do, and once you get all set up, then you can head over to the Chainlink docs, and you can run your own node to connect to the Chainlink Oracle. Or you can just connect to somebody else's node and work with some of these, make a GET request, find existing jobs, maybe even sync up with other engineers at the hackathon and say, hey, like, let's joint build a project. Let's joint build some crazy price feeds or something. But this is kind of where you can live. And if you're brand new, definitely take a look at that beginner walkthrough and look through that. But yeah, all the documentation is here. We're going to be in the Discord. There's a Chainlink support and an Agoric support that we're going to be in. So this is really the opportunity to get really creative, go through some of this documentation, and then just start building. You know, the sky is really the limit here with what you can do. Again, Monday, we're going to be going over that repo that I showed you to show you, exactly how to get some Chainlink pieces spun up on Agoric. If you're feeling ambitious, I absolutely challenge you to take a look at it yourself right now. With that being said, I know I only have a couple minutes left here. I will pause for questions. So it looks like there's a lot of questions here. Comments.
I'm going to join you as well, Patrick. We've had a number of questions and comments coming in through YouTube and then as well in Discord. If you do have questions for Patrick, please do send them in. We can address them now. We can also address them later. Patrick, again, you guys have been a great partner getting ready for this, and really appreciate the presentation and all the detail and ideas for hackers to execute on as the hackathon starts.
Absolutely. So I got like 2 minutes left here to do questions. The security app by Chainlink is a guarantee. Yep, you got it, Dot Man. The adapters for Chainlink nodes connect as Oracle contracts. Yeah. Okay. Yeah. Oh, maybe there aren't questions. Maybe it sounds like you guys are pretty with it. And I see a couple of engineers I'm familiar with. Hey, how's it going, guys? Yep. Yeah. Actually, it looks like you guys got it in the comments. Yeah, happy to take any other questions. It sounds like people know what's up. I see people talking about. We have a question on Discord private chat. Okay. Let me check the Discord private chat. Is it happening tonight? On fairness, who learns about the value first? Oh, that's an interesting question. So technically, the Oracle, learns about the value. I'm assuming we're talking about the Chainlink VRF here. Technically, the Oracle actually finds about the value first, obviously, because they're posting it on chain. But once it's posted on chain, whoever's listening to that contract and whoever's watching that contract will know. That is an interesting question, actually. But yeah, the Oracle learns about it first, and then whoever's listening to the contracts. So that's a good question.
All right, great. Well, Patrick.